For as long as I can remember, our screens have been, well, kind of boring, right? Just these flat, fragile rectangles. But that is all starting to change. So today, we're going to dive into the incredible science that's finally setting our displays free.
I mean, really think about that for a second. What if your phone could just fold in half and disappear into your pocket? Or your huge TV could roll up like a poster? Or, get this, what if a screen was just invisible, like part of your car windshield? This stuff isn't sci-fi anymore. This is happening right now. It's the cutting edge of display engineering. All right, so let's get into it. Let's look at the key innovations making all of this a reality. And we've got to start with the very foundation of the screen.
Okay, so if you want to build a screen that can actually bend, you first have to solve a huge problem. Its foundation. We call that the substrate. And for, ever, that's been glass. And that brings us to a major roadblock. So here's the fundamental problem, right? Glass is amazing at one thing. It's a perfect barrier. It keeps all the nasty stuff like oxygen and moisture out, which is crucial. But, and we've all been there, glass breaks, it shatters. And you just can't have that in a flexible device. So we needed to find something else. So, if glass is off the table, what's next? What are the contenders? Well, engineers basically narrowed it down to 3 main options. And each one had its own set of pros and cons. And this really breaks it down for us. You've got ultra-thin glass, which is a fantastic barrier, but hey, it's still glass, so it's fragile. Then there's metal foil. Super durable, great protection, but the surface is all rough and it's kind of heavy. And that leaves us with plastic film. It's flexible, it's light, but it has this one huge deal-breaking weakness. So yeah, for the most part, the industry landed on plastic. The flexibility, the low weight, it's just a winning combo. But remember that critical weakness I mentioned? Well, it all boils down to this one key concept, the barrier property. See, here's the thing. Unlike glass, which is like a solid wall, plastic is more like a screen door. Tiny bits of oxygen and water can sneak right through it. And for something as delicate as an OLED display, that is an absolute disaster. It causes dark spots, dead pixels, basically it ruins the screen. So the million-dollar question became, how do you get the awesome flexibility of plastic, but with the rock-solid protection of glass? And the answer? Oh, it's so clever. It's this brilliant manufacturing trick that literally gives you the best of both worlds. It's called the laser liftoff process. Okay, check this out. Instead of trying to build all those tiny, delicate circuits on a flimsy piece of plastic, they start with a sturdy, reliable slab of glass. They build everything on there, where it's safe and stable. Then, and this is the genius part, they shine a special laser right through the glass. That laser zap cleanly separates the circuit layer from the glass base. The whole thing just lifts right off. Then, they just glue that finished circuit layer onto its final home, the flexible plastic. It is such an elegant solution. But wait, there's more. Bending screens is just one piece of the puzzle. This same core OLED tech is also making 2 other mind-blowing things possible. Screens you can see right through, and screens that are absolutely gigantic. Let's talk about the first one, making screens disappear. Like in the movies, where someone waves their hand and suddenly a plain window is a computer screen? Well, that's real now, but to pull it off, engineers had to solve a pretty big electrical puzzle. So here's the deal. Every single tiny pixel on a screen needs electricity. That power is usually delivered by a thin layer of metal called a cathode. The problem? Metal isn't see-through. So to make a transparent screen, you have to invent a new cathode that's both transparent and can carry a current. It's kind of like trying to make a window that's also a power line. And the real tricky part is putting this new transparent layer on without completely destroying the super-sensitive OLED sitting right below it. Okay, now for the second innovation, making screens infinitely big. What if you want a screen that covers an entire building? Obviously, you can't just make a single pane of glass that huge. So the solution is pretty intuitive. You build it out of smaller screens, piecing them together just like tiles on a floor. This technique is called seamless tiling, and the goal is super simple to say, but insanely hard to do. You have to line up all those smaller panels so perfectly that the line between them, the seam, just disappears. It has to be totally invisible to your eye. And that's tougher than it sounds, because our eyes are really good at spotting imperfections, lines, and gaps. So when we say invisible, what does that actually mean? Just how perfect do these things need to be?
Well, this number really puts it into perspective. To make a giant screen with pixels that are 3 millimeters wide look like one smooth continuous image, you'd have to stand more than 10 meters back. Now, think about the seam between two of those panels. If that gap is even as wide as one single pixel, your eye will spot it immediately from that distance. It would totally ruin the illusion. So making that seam truly invisible takes an absolutely insane level of precision.
So let's step back for a second. When you put all these pieces together, you've got the flexible materials, that brilliant laser liftoff process, the see-through components, and the seamless tiling. You start to realize we're not just talking about better screens. We're talking about a complete redefinition of what a screen even is. So, to recap the key breakthroughs here, it all starts with using flexible plastic, but with special films to protect it. Then you have that incredible laser liftoff process that makes it all work. And finally, you have things like transparent cathodes and seamless tiling that let these displays either disappear completely or get unimaginably huge. And this isn't just about cool new gadgets. There are some serious real-world upsides. As the source material for this explainer points out, and I'm quoting here, their robust, unbreakable properties may become important for future mobile applications. I mean, think about that. Making our phones and watches stronger, even unbreakable, that's a huge deal for the stuff we rely on every single day. It's about making tech that's not just new, but better and more durable. So I guess that's the big question I want to leave you with. Once a screen isn't just a fragile rectangle of glass anymore, once it's this durable, flexible, maybe even invisible surface, where do we put it? Where does it go next? On our clothes? Integrated into our car dashboards? Wrapped around the architecture of our cities? The possibilities are quite literally just starting to unfold.